Hi. So today we will move on to the last part of matrix, which is matrix transformation. Are you guys ready? So before that, let's mark our previous homework first. So this is the answer for question 11, the last question. There are 3 questions altogether, right? These 2 questions I've taught you how to do. And yeah, let's look at your number 19 first. The other day, I asked you guys to find out the answer by your own, right? Okay, so the answer here is 140 and 145. Please tick your answer. And then let's look at this question, which was your homework. Okay, question 11, A, this is your answer. Okay, it's a 2 by 1 answer. And explain the meaning. It is total pay or total earning or total money, total amount, something like that. Which has the same meaning as the pay John received in week 1 and week 2 respectively. Okay, please check that week 1 and week 2 because these two represented by week 1 and week 2, right? Okay, let's move on to matrix transformation. Okay, matrix transformation, this is in 4B book. Okay, please get ready your 4B book, Discovering Maths 4B. Okay, your 4A we have done everything already, and 4B, okay, we have few more topics left. Okay, 4B, few more topics left. This topic is under chapter 7. Okay, if you have your 4B book, this is under chapter 7, and I only take one part of the chapter in 4B, which is your matrix transformation. So basically, matrix transformation is also coming from your matrix. Okay, the topic of matrix, I just combine it together, become in this lesson. All right. Okay, so matrix transformation here. Okay, you can see the word matrix and the transformation, these 2 words. All right, matrix, you already know what is it already, in this form. Okay, with a bracket and row and column. Okay, transformation, you have learned this in your year 9. Okay, transformation, let's recall back a bit on your transformation. Transformation that you have learned so far is reflection. Okay, and then we have rotation. We have translation. And we have enlargement. Okay, we have 4 of these transformation. Okay, we only have 4 only in all levels that we learned already before in year 9. We learned this already. Okay, and then what is it matrix transformation? Okay, these 4 of these transformations, right? Okay, all of the transformations, okay, which are related to all these 4, they have their own matrix. Okay, they can be represented by matrix. Okay, they can be represented by matrix in a unique matrix. Okay, they all have a different matrix, but they all have the same 2 by 2. Okay, for reflection, rotation, and enlargement, they have matrix that are 2 by 2, but they are unique. Unique as in they all have different values of the 2 by 2 elements. Right? Except for translation, you see I didn't take the translation because translation, it can be represented by just 2 by 1, like that only, x and y, right? This is a 2 by 1 and we call this column vector. Okay, this column vector represented as a matrix also, right? 2 by 1 is a 2 by 1 matrix. It's a column vector and represented by x and y. Okay, that's for only translation, right? And whatever we learn today, okay, we will go through one by one, and they all have their own matrix. Okay, they have their own unique matrix. Okay, how do we find the matrix? Okay, how do we know which matrix is which transformation? Okay, this is where I'm gonna teach you how to see. Okay, but first you need to look at this identity matrix. Can you see this identity matrix? This is identity matrix, 1 0 0 1. Okay. First, before that, what you need to know about this one here. This is your standard. Okay. This is a standard of x and your y, x1, y1, and this is your x2, y2. Okay. This is your coordinate. Okay. This is one of the coordinate 1 0, and if we represented this coordinate in a Cartesian plan, it will be here. This is your 1 0, and this is 0 1, right? 0 1 is here. 0, 1. Okay, so when you look at matrix like this, okay, you must see it as this way, x, y, x, y. Okay, not like this, it's like this, like this is considered first coordinate and your second coordinate. Okay, and this 1, 0, 0, 1 is the standard. Okay, before we move on to transformation, you need to know the standard first, the standard unit, okay, before we find what is the transformation matrix here. Okay, so you know this is x1, y1, x2, y2, your 1, 0 and 0, 1, they both of these coordinates are always standard. Okay, you've put it 1, 0, 0, 1 like this, right? Okay, so you know about this already. The next thing is, okay, translation, you know that is 2 by 1. Okay, when we say reflection x-axis, right, what is the matrix? Okay, what is the matrix that represented this reflection of x-axis? Okay, as I said just now, you remember the standard. Okay, your standard matrix there is 1, 0 and 0, 1, right? This is the standard of the matrix, it's 1, 0, 0, 1. And if we want to find the matrix represented by reflection of x-axis, what we're gonna do with these two coordinates, 1, 0 and 0, 1, is we do the same thing. Reflection of x-axis. Okay, so first we reflect this 1, 0 first, because your standard matrix is 1, 0, 0, 1, right? Okay, so we reflect this 1, 0 first, okay, under this x-axis according to this. Okay, so this 1, 0 will still be at 1, 0 because if you reflect under x-axis, this point here will still be the same. Okay, so it will be still the same 1, 0. Okay, and this y coordinate is 0, 1, right? If you reflect under x-axis, it will go down here. Am I right? 1, 0 will still be 1, 0. 0, 1 will go down, become 0, negative 1. So it will become like this. Okay, meaning to say that your standard matrix is this. It will transform from 1, 0, 0, 1 to 1, 0, 0, negative 1 under reflection x-axis, right? So this coordinate will still be this, and this one will go to this 0, negative 1, like how you reflect. So this 1, 0, 0, negative 1 is now your reflection x-axis. This matrix represented as reflection x-axis. Okay, you remember that, So it's either some people they memorize 1, 0, 0, negative 1 is a reflection of x-axis, or you do like how I do it, the technique which you remember 1, 0, 0, 1 first, and then you reflect x-axis, you see where is the coordinate go, and then you write it down here. Okay, alright, let's look at this one. What if reflection y-axis? What is the matrix of reflection y-axis? Okay, remember, you start off with 1, 0 and 0, 1 first, your standard matrix for transformation. Okay, 1, 0, 0, 1. Now you want to reflect y-axis. You must first reflect the 1, 0 first. So 1, 0 under y-axis. Okay, this is your y-axis. And you reflect, it will go here. So this is negative 1, 0. Okay, it is a negative 1, 0. So if it's a negative 1, 0, means that your matrix will now become negative 1, 0, right? And then your 0, 1 will still be here because it doesn't really reflect because it's already on the reflection line. Okay, so it still be 0, 1. Okay, I conclude here. Okay, your 1, 0, 0, 1, coordinate of 1, 0, 0, 1, okay, will go to negative 1, 0 and stay at 0, 1, okay? This one reflect, become this. This coordinate reflect, become, will still be 0, 1. Okay, so this is under reflection y-axis. So when they ask you, what is the matrix represented by reflection of y-axis? Then this is the answer. Okay, how to find this? You have two options. One is to memorize and one is to do the method that I teach you. Okay, and we have so many 1, 0, negative, all this. If you want to memorize, it's really hard, but some people can memorize. Okay, you can do that if you want. Okay, but this is the easiest method that I can think of. We can do it, okay? So again, 1 0 0 1 is here, 1 0, and then 0 1 is here. Okay, reflection under y equals to x. Okay, y equals to x line is here. This is your y equals to x. Okay, so first we reflect this 1 0 under this line. 1 0 will go to 0 1. So 0 1. And your 0 1 will go to 1 0. So this is your reflection of y equals to x. Okay? Okay, again, you start off with 1 0 0 1. Okay, and it will go 1 0 will go to 0 1, and 0 1 will go to 1 0. Okay, this one is going here, this one is going this. Okay, kind of easy, right? Boleh lah, huh? Okay, let's look at question 5. Okay, question 5, I want you to find it by your own, but I can tell you what is y equals to negative x. Y equals to negative x is here. Okay, and remember your standard is 1 0 and 0 1. You start off with 1 0 first, and then this is 0 1. So 1 0 will reflect here, right? And 0 1 will reflect here, right? Okay, so what is the matrix that represented by this reflection of y equals to negative x? Okay, I want you to write it down. Okay, right, that's for reflection, right? Actually, reflection, there are more. It's not only this. There are more reflection. These are just the example that I can give you, right? Okay, let's move on to rotation. Okay, rotation actually the same thing. You start off with 1 0, coordinate of 1 0 and coordinate of 0 1, and you want to rotate rotation of 90 degree clockwise about the origin. Okay, about the origin. So for matrix transformation, right, rotation is always with the origin. Okay, for your all level syllabus are all origin. Okay, matrix transformation are all origin. There's no other point. Okay, it's all origin. Alright, so 1 0, 90 degree clockwise, it will go here, isn't it? It will go here. This is 90 degree clockwise origin, so it will go here. So 1 0 will be at here is 0 negative 1, huh? So 0 negative 1. Okay, and then for this one, 0 1, this point 0 1, 90 degree, this is 90 degree. Okay, clockwise, this is clockwise going here this direction. 0 1 will now goes to 1 0. So 1 0. So that's the answer. That's the matrix that represented by rotation 90 degree clockwise about origin. Okay, and then let me summarize this again. This one start from 1 0 0 1, right? Okay, if you go rotation 90 degree clockwise about origin, 1 0 will go to 0 negative 1, and your 0 1 will goes to 1 0. Okay, here go here, here go here. Alright, that's for 90 degree clockwise about origin. And now question 7, rotation 90 degree anti-clockwise about origin. Now anti-clockwise, okay, again you start from 1 0 and 0 1. Okay, anti-clockwise is going this way. This one will go this way, 90 degree. So now you write down what is the matrix transformation represented by this rotation 90 degree anti-clockwise about origin. Okay, number 7 you do. Now let's go to number 8. Number 8, rotation 180 degree about 0 0. 0 0 is origin, by the way. Okay, so standard is 1 0 and 0 1. Okay, 180 degree. Okay, so 180 degree here will go here lah, a straight line. So it will go to negative 1 0. Okay, and then for 0 1 will go to here, 0 negative 1. Okay, so 1 0 will go to negative 1 0, and 0 1 will go to 0 negative 1. Okay, so far so good. Okay, right. Let's look at number 9. Okay, so we have done rotation, reflection, now number 9. Okay, enlargement. Okay, enlargement, you have scale factor and you have about origin. Okay, as I say, for matrix transformation are all about origin only. Okay, so scale factor K. Scale factor can be any number. Okay, any number. Okay, but if the number is smaller than 1, okay, is smaller than 1, for example, fraction, must be fraction. 1 over 2, 1 over 4, 1 over 3, this one will become smaller. It means that it becomes smaller, but we still call it as enlargement. Okay, and if we have scale factor with negative, okay, let's say negative half, it will become smaller and opposite direction. If you understand what I mean by opposite direction, you have a center, okay, you have a center, and if your image is here, if your object is here, your image will be at the opposite direction. Depend on become smaller or become bigger. If become bigger, the number will be 2, 3, 4 like that. If become smaller, it will be 1 over 2, 1 over 4, 1 over 3 like that. Okay, and if with the negative means it's going to the opposite side of the direction. Okay, that one you have to revise back again from year 9. Okay, so matrix transformation for enlargement is the easiest one, which is, I write down first, is K0, 0K, and your K is depend on the scale factor. Okay, I give you an example. Why is it K0, 0K? Okay, let's say if my scale factor is 2, let's say my scale factor is 2, it means that it will become bigger 2 size. Okay, it will become bigger 2 size. So if I want to enlarge this point from origin 0, right, it will become 1 and 2, double. So it will be here 2, 0 now. Okay, and if I want to enlarge this point will go to 1, 2 here at 0, 2, right? So it will be 2, 0, 0, 2. Can you see that? 2, 0, 0, 2. This is K0, 0K. So imagine if I want to enlarge this by scale factor 3. Then if scale factor 3 means that it will be 1, 2, 3, it will be at 3, 0. This one will become 1, 2, 3 at 0, 3. So it will be 3, 0, 0, 3. Isn't it? Right? So that is why you have K0, 0K. Okay. What if it's become smaller? Okay. If it becomes smaller, let's say scale factor half. Scale factor half means become smaller. Okay, so if it becomes smaller by half, 0, okay, 1, 0 will become 0, 1, okay, in the middle here, which is at half 0 or 0.50. And then 0, 1 will be here, half ma. So 0, half or 0, 1, 0.5, right? So you see your coordinate will become 1, 0 will goes to 1, half 0, okay, matrix. So half 0 and then 0, half. It will still be K0, 0K. Okay, it will still become K0, 0K. Okay, what if your scale factor is negative? Okay, negative means opposite direction, right? Okay, so if opposite direction is still the same, okay, 1, 0 and then 0, 1 standard. And now I want scale factor negative 2, for example. Okay, scale factor negative 2 means opposite direction. Okay, your 1, 0 is here, right? Opposite direction and double size, right? Here until here is considered 1. So 1, 2 here. So it will be at negative 2, 0. Double ma. Okay. Object to center is 1. So center to image double up. And then this one also same. Opposite direction. Here goes to here is 1. And then 1, 2. To the from origin to image double. So this is 0, negative 2. Okay, so your matrix will now 1, 0 become negative 2, 0, and 0, 1 will become 0, negative 2. It still be K0, 0K. See that? So conclusion, enlargement, scale factor, any scale factor K, it will just follow K0, 0K. So if they say enlargement scale factor 3, what is the matrix? The answer is 3, 0, 0, 3. Okay, and so on. Okay, so I hope you understand this one. Okay, today's lesson is only like this. Okay, what you need to do is just copy this down, understand it, and then do these 2 questions by your own. Alright? Okay, I've sent this to you through Teams, please print this out. Okay, if you couldn't print this out, you have no choice, then you have to copy down lah. Alright? Okay, I'll print this out for our next lesson. It's not for your homework, but for our next lesson use. Right, thank you guys. See you again. Bye.